What's up, guys? In this test we are going to determine whether or not this inline preheater can aid the ignition process of one of these waste oil burners. This particular burner operates under something called Brunelli's principle as far as how it pumps air and oil. It's a siphon nozzle. A female YouTuber brought that principle to my attention. I requested if anyone knew the name. I thought it was the Ventura effect or something like that, but she pointed out that it is in fact called Brunelli's jet principle. And today we're going to try to fire this thing up on pure waste oil. There is no gas in that oil whatsoever. We're not doing one of these scam YouTube videos where they show you how to build something that doesn't work unless you fidget the fuel blend a little bit there. So we're going to start off with 100 psi of air pressure, 200 watts of heat on the thermocouple. And we're going to see what happens here. This ought to be pretty interesting. Got to get the air bubbles out of the system at first, so it might get off to a rough start. But at any rate, this should be pretty cool. Let me get the thermocouple in place, because I do want to know what the temperature of that oil is. I will periodically be moving the camera for optimum angle and all that stuff. So, got the thermocouple here. Current temperature of the thermocouple is showing 55 degrees. It is quite cool outside here. I'm going to turn the air on. Get the torch ready. Some earplugs in. This thing kicks off about 100 decibels, which is definitely enough to damage your hearing. So if you're running these things for a forge or something or whatever, don't think that you're safe standing next to this thing. It's not safe. It's too loud. So here goes. You see the oil starting to come down the line there. I'm going to go ahead and as soon as that oil hits, I'm going to turn on the preheater with maximum air there. I want to take note of that flow rate. Probably can't see that oil. See it coming up the line there. It's just about ready. I'll turn this preheater up to 200 watts. No oil's coming out yet. There it goes. cool. So, as you can see, I ran into some problems there. My fuel stem broke. I'm gonna have to fix that. Definitely a failed experiment. I don't think I was pumping enough fuel from what I've seen in the past. I think I need to turn the air pressure all the way up to get this thing to work, which I don't know how good that's gonna be on my flow rate. Insulation caught on fire a little bit there, but no biggie. My overheat temp's going off. So, it did not aid in ignition whatsoever. Typically, as I said, I would start with a gas mix to get things lit. However, this was a failed experiment. I'm going to go ahead and post this and show you guys, though, to show you that it didn't work. Next time what we'll do is we'll get the thing lit, and then we're going to observe the effects of the inline heater during operation. I don't think I was pumping enough fuel. I think this is causing a big of enough fuel restriction, maybe. I could be wrong. But it appeared to me we didn't have enough fuel. And the way I know that is because if you're trying to light a waste oil burner and it won't light, but you're getting flame, and you don't see oil spraying out the front of it, you do not have enough oil. My experience has taught me that a good indicator that you do have enough oil during ignition is that you have too much. And the absence of any dripping out the front indicates in the past that was the tail. That when I didn't have oil coming out the front, when I finally got the nozzle dialed into where I could spray that much oil out, that was good for ignition. Then once it gets lit, it burns it. It gets hot enough and burns it all. So for now, I'm going to have to try and fix this solder joint. I was worried my angle may have been off, is what I was doing, fidgeting with this, so I was trying to bend it. But it became so hot from the preheater, I couldn't touch it. I came ill prepared, didn't have my gloves on, and all of that. So I just wanted to share with you guys one of the experiences of attempting to ignite one of these things. It's not always a cut and dry process. The videos you see on YouTube of them running like a champ are cool, but they rarely show the process of development and learning to get them actually going. So that was a failed test. Nonetheless, definitely a pretty cool experiment. And we now know the inline heater does not aid combustion. At least it did not in this case. But as I said, my siphon nozzle may be a little messed up. Might not have enough air pressure with this thing on there. This definitely restricts oil flow. And it is kind of cold, so that oil is about 55 degrees, I would imagine. I have a thermal gun. Oh, I'm sitting on it. Yeah, 58, 57. So, there you have it. It does not aid ignition. I will have to add a little bit of gasoline to the fuel just to get this thing lit, and that's exactly what we're gonna do. Okay, we're gonna try it one more time with pure oil. I'm gonna turn the pressure all the way up this time. Maybe that will help. Right, yeah, I wasn't even at 100 psi, that damn regulator. It's not always what it's cracked up to be. Here we go. Just showing the road. the oil. There's the wattage. Not enough oil. Oh wow, my line missed. Crap. Oil here might be hot. I'm at 360 degrees on my oil, which is not good. I'm going to turn the preheater off. I'm pumping no oil here. Something has happened. Yeah, having that thing too hot, it's causing problems. I think I might have damaged the solder joint. It got so hot. It is refusing to pump oil. Something has failed. You have to have this elevated, maybe? I don't know. Crap! Had it working for a minute. Shut the hell up. Okay. So the airline got so hot it melted on me. So I might need a metal airline. So far, this thing has proven that it can light the waste oil burner. It is causing some problems for it. I'm going to cut this off and redo it. And we'll give that one more try and see what happens. And I think that oil just got too hot. Made this whole thing burning hot. Because we were at 360 degrees on that oil at one point. Not cool. As 24/7 informed me, that will varnish up in no time and just end up clogging my nozzle. So not a sustainable configuration, but it did aid in the ignition. There was no gas in this oil whatsoever. Okay, let's try that again. All right, let's see here. Oh yeah, that sucker's a little warm. Should pump oil now. pumping enough oil. Okay, I'm gonna try this again. I'm not pumping enough oil. I know that to be the problem. So fellas, my observations conclude that this did in fact help the device ignite. However, it's restricting oil flow far too much. I have way too much oil flow restriction, which kind of defeats the purpose. I'm going to try and prove that by just going ahead and disconnecting this thing maybe, and just hooking up a straight oil line to show that it will run without any of this jazz. I just wanted to try this out. I was pumping 360 degree oil in this thing and it wasn't burning without some type of ignition. And I know this burner works. I do seem to be a little bit out of spec here on my position with my nozzle and all, but I can tell by the fact there's no oil on the ground right now. I don't have enough oil to sustain the burn. The flame, even when it does burn, is only out to here, and with 100 psi of airflow, that's just not enough. This thing's just restricting my flow too much. I'll have to figure something out. This little loop in the pipe isn't helping anything out. I might just try and take that loop out, see what I can do with that. But as of now, it seems like this thing's a failure to me. That's what I'm calling it. It did help ignition, but it's killing my fuel flow. I'd have to have an oil pump. So to kind of prove that, maybe I should go ahead and just hook up the oil pump. Quit screwing around with this thing. We'll do that real quick just for the sake of seeing if I'm right. If we can get this thing to run with the fuel pump on, then we know that it is restricting my fuel flow enough to inhibit combustion. So let's give that a shot. Okay, fellas, I have a fuel pump hooked up this time. We are going to attempt to observe the effects of the inline heater with an actually operating system here. I don't want to let the fuel flow issues end the testing for today. So we're going to cheat a little bit with this oil pump I built. We're going to run it at approximately 4 liters per hour, which is what this thing typically runs on. And hopefully we'll find some interesting information. Nonetheless, we will at least be stress testing this inline heater. Breaking the solder joint right there. Well, that was a lot of footage there, guys, but it would appear to me that for this specific burner, that the inline heater is an absolute waste of resources and time. So, not looking good for the inline heater at all. Not only did it render this device inoperable in its normal conditions, but it seems to even inhibit operation during actual optimum running conditions. So, I don't know if you saw that, but I saw the flame starting to have problems the hotter that oil got. Did anybody else see that? I don't know what was going on. Maybe some vapor lock was causing that sputtering. Some bubbling and stuff like that does affect the spray pattern at the nozzle. If you get bubbles downstream, you get this pressure undulation going on. We totally turned that 1,000-degree insulation into glass. Pretty much vitrified it. Almost entirely. Very interesting that this thing got so hot this time. And it's because I was able to adjust the fuel-air ratio with a little bit more control than normally. Turns out this pump has increased the performance of this thing tremendously by enabling us to induce an oxygen-rich flame. I've tried toggling the oil input before, and it turns out the nozzle was running at a point where it had just enough oil to function. And if you would tamper with that on the valve that I put on there, it would extinguish the flame, whereas a pumped oil flow under pressure seems to be a little bit better than a vacuum oil flow under vacuum. I was unable to adjust the oil flow previously. It would always cut the flame out. The flame would go out on me. And I think that the problem lied behind the concept of having a needle valve in line with the fuel inhibited flow so much the device wouldn't operate, whereas having a big gate valve or a ball valve would cause adjustability issues, where it's very hard to finally adjust a ball valve. I had a small ball valve about that size in length, about that big around, hooked up to it. And I tried to make that oxygen-rich flame we saw and was unable to do that. See these oil drips right here? Those are the telltale drips I was telling you about. If you're not getting that just a little bit of drip during ignition, you do not have enough oil to sustain a flame. Because the flame is not fully lit, some of the fuel will drip out. But once the system's fully ignited, this excess will be sufficient to achieve an optimum combustion. But if you don't see this when you're trying to ignite, that is a telltale sign that you do not have enough oil being injected into the system. You want to get a little bit of oil spraying out of the front of this bad boy, and that indicates you have sufficient oil. Even if it's just spraying out of the front of the thing, man, that will not inhibit ignition. The lack thereof is a different story. Too much, it will light all the same. Won't affect ignition whatsoever. Absolutely won't affect it. Too much air, different story, won't light. So there's a lot to be learned and tampering around with these things. I did put together a video that helps people who are trying to get these things lit. I've got a lot of information regarding some past observations that can help you battle through the ignition process. Because you've seen how long it took me to get this thing lit at first. I mean, that's pretty commonplace. But once I figured out this damn thing doesn't work and hooked up the pump, we were in business. I am digging the pump, by the way. Did you see how hot that thing got? I have never got this thing up to orange temperature before. Let's do a quick check on that. Let's see what the temperature scale is. Temperature color chart for emitters. Now, it doesn't matter what the material is for the emitter. You can tell the temperature of an object by its shade of color, irregardless of composition. Here's a good one. Oh, come on, for crying out loud. Jeez. At any rate, I want to say we were at dark yellow, guys. Wouldn't you agree? Almost bright yellow in the camera, but in real world it was dark yellow. I'm not gonna lie to you. In the camera it was bright yellow all day, which was really cool. Before we were down here in the bright red, 1500 Fahrenheit. Producing that oxygen-rich flame gave us an additional 400 degrees, which is pretty freaking cool. Isn't it interesting? The purple's 500 degrees, brown purple. Strange. So, at any rate, the experiment was somewhat of a failure, but I did figure out I probably never would have hooked this pump up to this nozzle. And I've just discovered that in fact it works so well with this device I'll probably never use it without it again. The heat we were getting off that flame, I guarantee you, was far hotter. You could just see that it had a nice cone to it. Very unstable, however. Another cool observation was, did you guys see that recirculation taking place? That recirculation wall that we saw is a very desirable trait in some burners. Let me give you an example of what I'm talking about here. On industrial applications and straight tube combustion systems, they will often have a tube like this, and they'll have an interior cowling about this big and a spray nozzle position, say here, in relation to that. And, well, I'm a little close. Let's back it out. And the spray would come in, the fire, you get a big old fireball blasting out of this thing. But because of the way fluid dynamics work, you would get a recirculation effect of fuel and fire. So you would have fire coming out of this region. There'd be like a firewall going on here. And that fire and hot air comes back into the cowling, aiding ignition. Well, what we just observed in our device was a similar effect. And where we have the nozzle here, we have the jet coming in, and we're getting this rolling effect right here. We're getting a rolling fireball, the same way we're getting a rolling here. If you look up diagrams of industrial burners, almost all of them will have this center cowling recirculator or some other form of that, or sometimes they'll use air streams where they'll have a burner like this. The air inside the tube is swirled, but just at the end of it they have air flying past it like this that is not swirling. And for whatever reason, I guess that also causes a little bit of an eddy current right here. And it's like a flame holder. It holds the flame, keeps the device ignited. That's what this is doing. This little rolling effect explains why the damn elbow's working, guys. I figured it out. It's because of that rolling wall effect. This acts as an ignition system to continually reignite the system. You know how it would work earlier with the blowtorch in there, but not without it? We end up creating a blowtorch right there that stays and sustains the combustion. The straight tube will not work. I've tried that nozzle in a straight tube. It just blows the fire right out the other end and won't stay lit. However, we're going to add this cowling they're showing, which will cause that flame rolling effect. I think I got to have this like back here, actually, to get the true effect. But that is why this elbow works, guys, and a straight pipe don't. I'll show you. I'll try and find a timestamp, but we're getting this rolling effect of a fireball is rolling right here. Actually, it's rolling this way. I'm sorry. It's rolling that way, reigniting everything. And that explains why the elbow works. Kind of interesting. And as you remove this valve, ooh, that thing's still hot. You lose some of that roll and it turns into a pulse jet where flames are spilling out over the side and reigniting the next combustion phase. Man, I talk a lot.